All right, so let's go ahead and talk about the idea of relational data. So where does this fall in our little pipeline of data science? This is kind of a transformation task. This is where we are manipulating the data frame of interest based off of additional data sets that can either add information to our data frame, or maybe we want to filter our data frame based off of observations in another data set. All right, so this is a great quote. It's rare that data analysis involves only a single table of data. Typically, you have many tables of data and you must combine them, right? So the idea is most organizations collect different types of information. And lots of times, these different data sets that contain these different bits of information can all be connected one way or another. So lots of organizations that may be focused on customers, right? You can have customer IDs, and the data for the transactions these customers make may reside in one table. Maybe the demographic data related to these customers are in another table. And maybe we have a table that's dedicated on product information, right? These are different tables that may reside separately, but they can be connected by a common attribute within them. Okay, so what we're really getting at here is joining data, right? When we have what we call relational data, separate data sets that are related to one another based off of certain attributes, we can join them. And we join data for primarily two different purposes. One is mutating joins. So mutating joins is the idea that we're going to add new variables to one data frame by matching observations in another. And then there are filtering joins. And filtering joins are, we're not going to add information to a table, but what we're going to do is we're going to filter observations in one data frame based on whether or not they match an observation in another table. Okay, and so all these joins that we're going to go through, these are provided by the dplyr package. And we saw the dplyr package a few lessons ago when we were doing some basic transformations such as filtering, selecting, summarizing, reordering with a range, and so on. We can continue to use additional functions within dplyr that are focused on mutating and filtering joins. All right, so to follow along, we are going to first go ahead and load the tidyverse package, which we're really mainly using the dplyr package, which is provided by the tidyverse. And then we're going to use this sample data here. This is basically creating two very simple data frames, which we see a picture down here. You can also see on the right-hand side within my R console. We have an X data frame that contains a variable called key, and then a variable called value underscore X. And then the Y data frame also contains a key column and then val underscore Y column, okay? Two very simple data frames. And with these, we'll illustrate the different types of joins that we can do. Now, on your end, to complete some of the actual exercises we're going to do, you're going to be using the complete journey data. Okay, and we're going to use the transactions data, the products data, and the demographics. Now, if you remember from when you went to the Complete Journey website, and this was going back in one of the very first lessons, you took a look at the documentation for Complete Journey. And it actually contains something like 8 different data frames in that package, and they're all connected, right? We have transactional data, we have, in this case, product data. So this has product information for each product ID. And we have demographics data. So this is information for each household ID. Right? We have some other data frames, but we're just going to focus on these 3. And these 3 can all be connected based off of certain variables within these data frames. All right, so first let's talk about keys. So keys are variables that connect pairs of tables, right? The keys are the common attribute between 2 tables that allow us to join them. So we use terminology to refer to these keys. We can call them a primary key or a foreign key. A primary key uniquely identifies an observation in its own table. Okay, so say we're focusing on the transactions table. right? Household ID would be a primary key that identifies an observation in that table. Now, a foreign key is one that uniquely identifies an observation in another table, right? So I could say household ID is the primary key within transactions, and it is the foreign key that connects us to the demographics data, all right? Now, in this example data that we're using, we see we have that first column, which if we look over here on the right, we're calling that key. That is our key, right? It just so happens that we name it key, but most of the times we do not name our primary and foreign key columns as key. But we can see we can make connections, right? We have observations 1, 2, and 3 in X. We have observations 1, 2, and 4 in Y, right? So we have a common attribute where we can align observations in both of these data frames. Now, in the exercise data, we have two different keys that we're looking at. So within transactions, we have a product ID variable, and that is a key that will allow us to join with the product's data. Now, also within transactions, we have a household ID variable. Now, that is a key that will allow us to join to the demographics data because demographics also has household ID in it. All right, so let's first talk about mutating joins. So mutating joins come in a couple different variants. The simplest and probably one of the more common types of joins is the inner join, okay? So the inner join will keep all observations where the key values match in both tables. Now, if there are key values that do not match, we will discard those observations. And then what we do is we add variables from Y to X, okay? So this is what this looks like when we actually write in the code. X, we're gonna pipe this into inner join. So another way to write this would be inner join, and then the first argument would be X, second one would be Y, and then we can specify what do we want to join by. In this case, it is the variable called key. And so what happens is, since X and Y both have observations, or both have observations where the key is equal to 1 and 2, right? Those are two common rows or observations within these data frames. We can connect that information, and we can join the added variable in data frame Y to the data frame X. Now, if we look at X, we have a key value 3. We don't have that in Y. And in Y, we have a key value 4, which is not in X. So we drop those observations. And what results is a data frame that has two observations where those keys matched in both the X and the Y data frame. And then we've added the column from Y that was not already in X. All right, so that's an inner join. Now, the rest of these joins that we're going to look at that are mutating joins are all what we call outer joins. Outer joins keep all observations that appear in at least one of the tables or one of the data frames. And there's three primary outer joins. First one is a left join, right? So left join is we are going to keep all observations in X, right? Or all observations in the first data frame that we supply to left join, right? So here we pipe X into left join, going to join it with Y. We're going to join by the key variable. And what we get is we keep all of the observations that were in X, right? And what we do is we add the values or the column from Y to the associated observation. But for that observation where we don't have a matching key in Y for that one in X, we fill in with NA or a missing value, right? So note how missing values get filled with NA here, right? So we're saying keep all of the observations from X and join what we can from Y, and what we can't join or what we don't have a match for, let's add NA for missing value. Now right join is the exact same thing, it's just the opposite, right? It's the inverse. It's where we are going to keep all of the Y observations, and we're going to join what we can from X, right? So left join, right join, it's all just comes down to which of the two data frames do you want to keep all the observations from and match what we can from the other one. And the last one is a fold join. And a fold join is just saying, I want to take all the observations from both rows and join them together in one observation. And wherever we don't have matches, we fill them in with NA or missing values. All right, so here's kind of an illustration of the differences between a left join, a right join, and a fold join. All right, so what I want you to do, go ahead, stop the video, and I want you to take the transactions in the products data, and I want you to apply an inner join. And so what we're going to do here is we're actually going to join those observations where we have matching product ID values in both transactions and the products data. So we're going to be joining, or the join key is the product ID variable. Number 2 is join transactions, products, and demographics data. Right, so we're going to have to actually use 2 sequential inner joins to join all 3 of these data frames. Now, the join key for transactions and products is the product ID variable. The join key for transactions and demographics is the household ID variable. All right. So I hope you got through that. The first one here is we're just taking transactions, and what we want to do, let me make sure I have transactions loaded. Now what I wanted to do was take transactions, which if we look at, transactions has a product ID variable here, and products data has a product ID variable here, right? That's our key variable. So we can match based off, or we can join based off of matching values in both of those columns. So I'm going to take transactions, and I'm going to apply an inner join with products, and the key that we care about is product ID. And now we would join, and you can see down here where we have the additional columns in here. We now see we have all the transactions data, but then we have the different additional variables from the products data, such as brand, product category, product type, package size, and so on. Now, one thing to note here before I look at number 2 is we could actually do this, and what if we don't supply the key argument? Well, what's going to happen is inner join is going to take a look and see, are there any common variables between, commonly named variables between products and transactions? And it will identify that. So here it says joining by product ID. So identify that product ID is a common variable between the 2 tables, and it'll automatically join by that. All right, number 2, you can see here what we do is we take transactions, we do an inner join with products, and then we follow that up with another inner join with the demographics data. And in that one, we need to specify that the key variable to join by is household ID. And so what results here is we have 24 columns. Now we have all the columns from transactions, all the additional columns from products, and all the additional demographic data from the demographics data frame. All right, next up, let's talk about filtering joins. So we just discussed mutating joins. And the idea is that mutating joins will always add variables from one data frame to the other one that we're joining with. Filtering doesn't actually add variables from one table to the other one. What it does is it simply filters observations where we either have or do not have matching observations in the other data frame. Okay, so the way to think about this is there are 2 primary types of filtering joins, a semi-join and an anti-join. And we use these when we want to filter one data set based off of the values in the other. A semi-join is going to filter where we have matching observations, and an anti-join is going to identify those where we do not have matching. Okay, so they just act in the inverse fashion of one another. All right, to illustrate, if we were to do semi-join with our example x and y variables, semi-join is going to keep all observations in x that have a match in y. Right, so we see we have the key values match for 1 and 2 in x. They match those in y, but we don't have a match for key value 3. So what happens is we filter out key value 3, and that remains or it ends up resulting in a data frame of x with the key value 3 removed or filtered out. Okay, so think of it this way. All we're trying to do is identify which observations have a match in the other data frame, and we're going to keep those, and we're going to filter out the other ones. Now an anti-join is going to do the opposite. Anti-join is going to say, find those where there is a match, and we're going to filter those out and just keep the ones that do have a match, which we see here. So the way to think about this is, say we wanted to look for all those transactions in our transactions table where we have basically, let's see, we want to find all transactions where we have households that we have demographic data on. Right there, what we'd want to do is a semi-join. We'd want to identify where all the household IDs and transactions have a match in our demographics table. And that would tell us, yes, these are the transactions for those households we have demographic information on. If we wanted to say, hey, find all those customers or all those transactions where we did not have demographic on, then we'd end up using an anti-join. We want to find those household IDs that do not exist within the demographics table. All right, well, so put this to test now. Here are the questions. Number 1, of the 800 households in our demographics data, how many do we have transactions data for? And then the number 2 is, of the 92,000 products in our products data, how many are not represented in our transactions data? Okay, so the key thing here is to think about, what are we asking? Are we asking, are we trying to find those observations where we do have a match in the other table? Or are we trying to find where we do not have a match? And that's going to tell you, do I use a semi-join or an anti-join? Here's a tip. After you use the joins of interest, go ahead and pipe the result into tally. And tally is a function that will just tell you how many observations are in the resulting data frame. All right, good luck. All right, so this is kind of what it looks like. So number 1, of the 800 households in our demographics data, how many do we have transactions data for? So here what we're trying to do is, we want to filter those household IDs that exist in demographics, and we want to find the ones where we have a match in transactions. And that'll tell us that that particular household has made a transaction that we have a record for. So if we do that, and then we tally the total number of observations, you would see we have 801. So we have, let's see, let's look at demographics here. Demographics, 801 different households. What that means is that every single household that we have demographic data on, there's at least one or more transactions made by them, right? So we have transactions for every single one of our households. Now, question number 2, of the 92,000 products in our products data, how many are not represented in our transactions? So this would be an anti-join. We want to find those product IDs that are in our products data that are not represented in our transactions data. And when we do that, here's products, we're going to pipe, we're going to do an anti-join, and then tally, we have 71,434. So that means of the 92,000 products that we have available, there are actually 71,000 that have not been represented in our transactions data. All right, so here's a quick tip to just have in the back of your mind. Not always do the common variables that connects two data frames, they are not always named the same in both data frames, okay? But that doesn't limit our ability to do these joins, right? For example, say we have our X where the key variable is named key 1 and Y, the key variable is named key 2, right? We can still match these data frames even though the names of this common attribute are different. And the way that we do that is when we do a join, and this is inner join, left join, right join, any of the joins. All we need to do is where we specify what key we're going to join by, we simply say by, and then we do key 1, or the name of the key in the first data frame, equals the name of the key in the second one, right? So this is the syntax we would use. And that allows us to match data frames that have a key variable that does not have the same name. All right, so one last challenge. We're going to start combining a bunch of the different capabilities that we've been learning over the past few lessons. What I want you to do is I want you to identify the top 10 product category items that have the largest total sales value for those customers that are 65 years of age or older. All right, there's a lot going on there. Pause the video, kind of reread that a few different times, and I have included the steps that you'd want to take along with a little bit of description to help fill in the blanks. See if you can complete this and identify the results. Okay, so what it looks like here is, first step is we want to take our demographics data and we're going to go ahead and filter for those households that are 65 or older, right? So this, I know that this was later on in this statement, but a big part of this is reading the question of interest and figuring out what are the analytic steps that we can take to get there. Now there's a couple different ways we could do this, right? We could have just joined all the data first and then filtered for age equals 65 after the fact. That would get the same results. The benefit of filtering before we do joining is when you have very large data sets, they can become computationally intense to do joins. So filtering out unnecessary observations before you join is always beneficial. All right, so we take the demographics data, we're going to filter for those that are 65 or older, then we're going to go ahead and join our transactions and our products data. Now I group by product category, and I'm going to compute the total sum or the total sales value for each product category. And then if I arrange in descending order, I'm going to get the top so many products that had the largest total sales value associated with them. So we can see coupon and miscellaneous items had the largest total sum, followed by beef, soft drinks, and then milk products and so on. All right, so just a few things that are really important to remember. We have two main different types of joins. Mutating joins when we want to add variables from one data frame to the other, and filtering joins when we want to just simply filter observations from one data frame based on whether or not they are represented in another data frame. Okay, and there's several different joins we can use for mutating. You can see them here. They're inner, left join, right join, full join, and it all depends on what type of data do you want to retain. Okay, for filtering joins, we have two, semi-join and an anti-join. And then keep in mind that we don't need to have keys that have the exact same name in both of those data frames. They can be named differently, and we can use this syntax in any of our joins to align and say that those variables are common keys. All right, if you got any additional questions, I would say, first of all, read the lesson. There's additional images that kind of help to solidify the concepts of these different joins, more code examples for you to work through. And then if you still have additional questions, hit up the discussion board in Canvas.